Welcome back to the stream, everyone. Bits are flowing. Looks like we're going live on YouTube on the Scanlime-in-Progress channel, as well as twitch.tv/scanlime. And you can get the bits directly from the shop at live.diode.zone/scanlime. And it looks like we are live in all of those places. I've actually got a good view of Tuco right here if he holds still, but I don't think he will. Well, maybe we should go back to the camera for Tuco. Anyway, welcome back to the stream. So the cat camera is currently in need of a little bit of repair. One of the winches is, well, this one needs a new motor, or at least a new gear, but probably a new replacement gearbox. So that's a little annoying. This is the second time we've had the same kind of failure occur, and it's obviously a design flaw, but it's hard to fix without a major redesign, and there's many things we could fix, so it's not like a major redesign wouldn't be warranted for other reasons, but it's one of those things that I've been trying to put off just because of how many other projects I'd like to do, and it's harder to justify spending a bunch of time on making another revision of the thing that already exists rather than making a new thing that we can make a new video about sometimes. So anyway, this was going to be kind of a chill stream, perhaps. I didn't have a new project to crack open and film here. I'm actually trying to make more edited video, which is usually the opposite of streaming. Like usually when I'm streaming, I'm filling up my storage devices with video that I then need to do something with. And this, the video that I'm currently trying to edit, I'm trying to do something that's a little bit more than just editing together like a collage of stream snippets. Like I actually want to do scripting and additional filming for that. So the amount of work that that we've already filmed basically for that video is an even smaller proportion of what it actually needs in total, which is even more frustrating. But the stage of that I'm in right now is I'm still trying to figure out from a research and scripting point of view, like what I actually want to do with the rest of the video, but there's a bunch of early stage editing that just kind of needs to happen in about the same way no matter what. So mostly just doing that. I'll see if I can try to get Tuco at least kind of on camera, even though it doesn't have all the winches running right now. I can still run this in manual mode with 3 of the 4 winches, I think. And it's actually a little bit more stable with 3 wires, but it can't address nearly the entire room. It's limited to a triangle. So there's that trade-off. Yeah, it's very different to drive with 3 of the 4 wires. It's interesting. It's also a lot more confusing. There we go. Hard to get Tuco away from that speaker. Oh, I might have to do. Anyway, so with this video editing, I don't know if it's going to be a more successful stream if I have the audio for the editing go into my headphones and not to you, or if you can also hear what I'm editing. I think at first I'm going to try just having all the audio mixed together, but if that's annoying, then I might end up running the editing software directly to my headphones, and then you and I are just listening to whatever we decide to talk about. So that's certainly an option. And I'll try to keep an eye on chat, even though this is mostly a co-working stream. Oh, I'm also gonna have to rearrange this because I usually edit on a much bigger monitor. We can just put all of this stuff up here. Okay, and this is also multi-camera, but I often have the multi-camera view turned off just so that it's less choppy. Okay, so this project, this is actually the little button switcher that I've got on my desk right now. It's this thing that clips on or velcros onto my keyboard. It has 4 buttons, and it switches the keyboard and other peripherals between 4 different computers. So it's a modified USB device switcher. And I think there are a lot of different ways I could take this, and different ways I could kind of break that project up into multiple videos if I wanted. I guess my idea for this video had been that, just thinking about like, well, what is the thing that I'm most interested in making a video about with that project footage? I think it's actually the Charlie plexing variant that we did, the two-coplexing, which I think is an interesting thing on its own, and maybe a good lead to get people interested in the video itself. But then I think it's an interesting opportunity to talk about a few other things, I think a lot of people don't really think deeply about how Charlie plexing might fit into a broader framework of LED multiplexing, and it might be an opportunity to bring up a couple of ways to think about that. Maybe also some of the history behind Charlie plexing and then multiplexing in general, I think might be pretty interesting. I was doing some research about that, and yeah, it's interesting because I feel like Charlieplex is this word that came out of the Maxim semiconductor marketing literature, and then just kind of got adopted by everyone without really a lot of additional information going into subsequent articles about where this came from, or and so people know that yes, this was just something that Charlie Allen coined. Charlie Allen was an applications engineer at Maxim Semiconductor. And we know that this was one of many bright ideas he had in trying to come up with a way to map the features that he thought that the engineers out there wanted to the silicon that he thought that Maxim could develop. So, there's a little bit of information about where his role was in that system, and why he coined that name, or why that name came about. But it's I'd really like to find an oral history of exactly how that happened. I think that would be super interesting. So if anybody has any leads on that, let me know. I've gotten just slightly close to that, just finding some oral histories of other folks at Maxim, and the occasional article or something that quotes somebody. But yeah, I haven't found anything specifically about Charlie, so I thought that would be interesting. But then I also thought that would be an interesting jumping off point for talking about how so much of our technology is named after people that we either don't know or that we'd prefer maybe not to remember, but we just kind of end up stuck with that name anyway. So, I don't know, that might be some interesting premise there. I thought it would be interesting to do something that was scripted and kind of more narrative-driven, but still really used this project footage as another one of its narrative elements. So, I don't know if there's a name for the narrative technique where you just kind of weave together multiple plot lines, but, I wanted to do something kind of like that where maybe one of the plots here is this thing that I'm building. Maybe another one of the plots is a justification for it. Another one of the plots is how it's used afterwards, and all of those kind of unfold in parallel. But yeah, that's the idealized vision of this. Just in practice, looking at the video footage, though, there's just a lot going on here, and it might be worth even splitting this up into multiple separate videos that'll have a different focus. A lot of the stuff I've been editing just the last day or two has been deep reverse engineering kind of stuff, and so yeah, part of what I want to do is just get a sense of like how much of this I have, like what is actually worth showing, how much is there like by weight, how like what form do I want to get that into, and trying to think more about for all the stuff that I'm doing, all the projects, the footage, the ideas, like anything that I have that I might want to share, like what is the audience for that and how do I get it into a form where that theoretical audience might actually find it. Yeah. And this is part of what I just feel like completely helpless at. Like I really, really don't know what I'm doing with regard to like internet content. I find the whole process really frustrating and kind of appalling, and I have a hard time really engaging with it. So that was actually where that the little perler bead robot video came out of. I had this this very small release recently that just came out of some of the extra footage from this project. Maybe a bit of a story time tangent, maybe. I don't know if these have... Yeah, so I just made this little video recently, which is about a completely different project. It's about this old perler bead printer thing and the old 3D printer that I used to make the parts, and it's just apropos of nothing else in this pile of footage, so I just turned it into a separate video. But when I do this, I always feel a little bit disappointed because I feel like I'm just kind of throwing stuff against the wall. Like I don't really have a good reason to, I don't really have a good reason to care about this. It was like a random art thing that I did many years ago, honestly, mostly to teach myself how to design stuff with 3D printing and as something that on a whim might have turned out to be interesting, but that I didn't actually finish because it was really big. Yeah, so I've got all of this footage so far in this project, 8 days, looks like. And Adobe Premiere has a limit of 24 hours per sequence, so I actually had to break this into a few separate sequences. So these are kind of arbitrary boundaries, but I think these were each about the same size, like 18 hours or so, and I've been editing them down. So yeah, I'm just gonna be editing. Let's see. I don't know if I want to go through everything I've got so far in this, but just like skipping around briefly. It's normally very tiny and hard to locate. It's a little LED indicator that tells you which computer you're attached to. And so the idea is you have one USB Type A host here. It's labeled output. And then you can just switch that between 1 and 4
it starts
upstream
with
ports.
me just
These
like
confusingly
really
also have Type A host
basically explaining what this thing is.
This is not actually explained. It's like a... So the one you see,
Adobe Premiere lags a lot less if I turn off multi-camera.
you see here, this is a Mac Mini that I use just for the streams. It's labeled Fishbowl. It's the one that everyone's watching.
Yeah, like a lot of this stuff is not very good. This is still just the first pass editing. Like a lot of this stuff is still pretty fluffy. It's like stuff where I might use only the audio or the video. I might not use it at all. I might have just saved it because I was worried about a plot hole if I didn't keep it. But
so this was just, something that was kind of, cheap on Amazon. It has Velcro on it because I usually stick it to the side of the desk. Usually it doesn't. Usually there, I guess you can see what's written on this. This Velcro is really hard to get off though, so I'm not even going to try. Unless we have to. Nothing to do though. So yeah, not the interface I prefer. I see some actual switching elements for connecting this to one of these. That might be a simple just analog switch. I'm curious what you use. If it's that simple, then here's the tool enough for taking the use from scratch, but I'm curious. And then there's like some controller for that. I'll just,
a lot of talking.
Yeah.
Yeah.
So far. Okay. So like a lot of this would fit into the framework of a kind of standard YouTube techie video teardown narrative, whatever. It's like I find myself really unexcited about those videos a lot of the time, but I could make one of those. Maybe I should, and then just do the exciting parts elsewhere. I don't know. And then U1, U2, U3 are all switch chips. So 7030. Yeah, so all those switch chips are the same. U3, U2, U1. STM8.
I should keep an eye on my levels. Sorry.
They're like low-end parts, but I think this is an 8-bit chip from ST. So there may be a few interesting things about just this part of the project even. So it's an 8-bit architecture that maybe not a lot of people have seen. The STM8 was certainly new to me. I was just feeling my way around this thing the entire time. And then so maybe that's an interesting aspect of this, the whole process of
doing some development on a chip that you're completely unfamiliar with, maybe there's some interesting story there to tell. There's the story that a lot of people seem to be interested in, which is how do you do any of this without an Arduino? And it's like, well, that's kind of the territory we're in right here, because there's no Arduino port for STM8. Wow, and it's got an unused IR input. I'm guessing this line with the 0 ohm resistor is maybe an enable. And I would and then some of this is kind of the like mystery story of uncovering, like, oh, what is all this stuff in here? What does it do? That kind of thing.
Maybe that's what they've set with the 0 ohm resistor. It's got one of these for each port. Maybe this was just two different designs for how they wanted to do the power, like the current junction here, either using diodes which have more of a loss, or by using a transistor which would have less loss. Like this could be a MOSFET configured as like a reverse protection circuit. Oh yeah, STM8S 003F3 mainstream value line 8-bit CPU. 16K flash, 16 megahertz integrated EEPROM. Single wire debugging, which might be that 4-pin connector we saw. Oh no, SDCC. Okay. I mean, I can stomach writing code for SDCC again. I just keep telling myself I'll never do it again. Every project I do with SDCC, I'm like, I'm never using this compiler again. Yeah, I'm sure it's less painful to just desolder the STM8 and put an Arduino on there, but it would be interesting. You could just reflash it. It's got plenty of I/O too. What's that about clocks? 128K RC oscillator and 16 megahertz RC. They've got a C compiler. They're probably gonna make you pay. Kind of motivation to ready for this processor. It's impossible. So that could be some white ground. That's reset. The micro will bring each of these low light LED. Looks like going to individual pins. It's also power sensing for ports. So this is still a voltage ladder. So it's got some and a 3.3K. I would expect one of those for each port. Because I think the strategy here is going to be desolder the main chip and just put an Arduino on here or something. I think that's going to be what to do. How many? I mean, it's also one of those things that I do on like the second or third editing pass. Is like, how many times did I say that? Let's theoretically another way. I also don't know how much of the original dialogue I'm using versus how much I'm narrating. I think what I want to do in most of these videos is to sort of narrate voiceover, but then mix that with original dialogue where that makes sense. But I think a lot of the problem that I have with just like the flow of some of my existing videos is that I don't have enough additional narration to make things make enough sense to folks who are not already familiar with what's going on. So I don't want to have that problem. Would be to either use this IR input, figure out what it's expecting, leave the original firmware on here, or to return the firmware and do it time protocol that tells people to work and just use filters straight away. Yeah, one is voltage sense or down for D. It's got a lower circuit for the down button. This resistor would install and move it to faster, still the power sensor. That's round. And this is the idea. Let's see, I expect the firmware that might support the IR sensor. That's cute. I mean, I would expect that the firmware they have loaded on here might support the IR sensor even if they didn't have the IR sensor fitted. So I think that's roughly the switch we've got. These are linked. This is... I'm going to render a few things while I pour my coffee. I guess it's too fast. Cool. Video editing is so hurry up and wait. I feel like so much of the time, either things are so fast that I'm, it's just fine, or I'm just, and then like I'm the bottleneck and I've just got to like do my thing. And then sometimes I'm just waiting on the computer to do something dumb, like, and I'm learning some of those. Like I used to get really annoyed at projects where, every time I play a preview, it sits there and renders the audio for minutes and minutes. And then I realized, a lot of that time it's because it's actually doing sample rate conversion. And if I fix the sample rates, then it wouldn't do that. I've learned stuff like that improves the workflow. Yeah, that still does factor into the workflow a lot. Like I mentioned that sequences can't be more than 24 hours. So one thing that I was trying to do was just make one sequence that has all this stuff in it, but sped up. But if you have all that sped up video, then any kind of previewing is going to be slow because it has to at least render the audio at time stretched. If you don't have the time stretch option that preserves audio frequency, then it's faster because it can do that in. I don't know why it only does that one in real time. Because it does have an algorithm for doing real-time frequency preserving audio time stretching. It just doesn't always use that, so I don't know what's going on with the architecture there. Because like here, it takes a sec to start, but I can play it forward or backwards at any speed without it rendering previews. But if I had one of these clips sped up, and then I just pressed the L key or whatever to start playing, then it would force me to render. So it doesn't seem to be entirely just related to the playback speed, but maybe the the entire mechanism they're using to speed up the real-time playback versus the clip speed is totally separate. So I think that's roughly the switch we've got. These are linked. This is probably an inverted enable, but it's muted. So I'll just text on that side. Plus minus capacitor, unused. I was going to enable resistor on hand. There it goes. And there's another one here, so unused, but wired to be potentially connected to enables. Set of debug strings for this firmware. IR command. Cool. It's interesting the IR mode command channels are named after video formats. I wonder if it's a video switcher firmware that is modified to a video switcher. There's a to a resistor to ground, so maybe that was for setting the run mode. They just went on the updated or using firmware afterwards. Yeah, this is very easy firmware. Just connect the tool. This is Zinc code 78. I am not familiar with the vector. We tried to set it. It'll become fun. I plugin. It's useful to more than I have a old list here. I like the way from edit files. Like, where's my hands old? Adding more edit tooling here. Oh, an IDA plugin. 6 years old took me to work in my IDA. That's funny. I've got a really old IDA license. I like the way from IDA files. Like, where's my hands old? I've never heard of this assembler, but let's see if I give it a shot. Does it need an assembler? Oh, that makes more sense. After the data segment. Yeah, so I've got this stuff which is basically one pass of editing. About 25 minutes of that, which is mostly just taking the thing apart, doing a little bit of like UR here, mapping out what's going on, and then diving into writing some firmware. Port 5005, bit 10 is either low or high. And then down here, same port, different bit is either low or high. So I don't know why those two least significant bits aren't just the same pin. They only set the one they're using, but the other one like could have changed. I don't know why they don't just use the same GPIO. Well, I guess we could use SDCC. You are clear. But it's not called anywhere. Let's see if we can link an LED. The LED for channel 0 is this one, GPIO port 5000A, bit 7. It's tempting to start doing the kinds of things that I would do in typical like ARM embedded programming, where maybe I have like a global volatile red like const pointer that points to the GPIO and I like index relative to that. But like when I'm writing code for SDCC, I trust it to do approximately 0 optimization. So like pound defines with constant folding are a little more surefire maybe. ODR, IDR, DDR, and then 2 control registers. What do those even do? Interrupt capability and or IO speed. Okay. And I certainly can't use C++ here, as nice as that would be. Alright, so decided to push pull, which is what we're going to want here. We need CR1 high and CR2 low, and DDR high. All that abstraction we're leaving on the table here. That's fine. Low is on for these LEDs. Let's just see what that does as a starting point. This code's not terrible so far. Let's see if we can run this. I don't see anything. We could just produce a high frequency square wave, which might look like a dim LED. Let's see if that does anything. Oh, that's right. I was going on a debugging tangent, and I was just going to kind of trim this until I get back on track. Save my place. Like we just produce a high frequency square wave, which might look like a dim LED. Let's see if that does anything. Oh, that's something I'm like on ST. This RST, by the way, is relocated, so now we've got an inner vector table. Here's a little trophy means this pin actually doesn't need to be push pull. This could be open drain, but I think that's the problem. I wonder if it's just going to turn on globally. It's not just turn on the entire GPIO controller. Oh, SDCC 11? Is that a real thing? I'm not going to make fun of SDCC. I had a dash L STM8. What does that mean? Library? Why are we specifying that manually? I feel like most of that isn't necessary.
Oh. Yeah, I might be trying to calculate SDCC here. I could let you build this by specifying what kind of pointer this is. This is just me failing to call SDCC properly, I think. I think I'm just generating code for the wrong architecture or something. Oh, man. Let's make this complicated. It'd be a lot more fun to edit if it didn't take so long to start and stop
Here,
playback.
like, if you don't pass the pointer across a function boundary, then I think it's not the same kind of deal, because the opposite function doesn't need to use data. If you pass across a function, it needs to be able to figure out what data type it is. So I thought I could specify the pointer as a data pointer, not a generic pointer, but I'm just trying to do that.
Certainly better than it was on my previous editing setup, but that seems to be the UI bottleneck mostly.
I think all the SFRs are bytes, so it's going to be like a byte SFR.
Yeah.
This is USC, I'm going to first of all. Yeah, this compiler frustrates me so much when I try to use it for big projects.
I'm just going to complain about SDCC for hours and hours.
Yeah, this compiler frustrates me so much when I try to use it for big projects. It's trying to do things best, it still does end up with kind of messy binary, in addition to code you want. But when I was using SDCC for that basic project, there are a lot of confines with NSW, it's kind of terrible. This code's not terrible so far. Let's see if we can run this. Disable here, that's fine. The low is on for these LEDs. Let's just see what that does as a starting point. This code's not terrible so far. Let's see if we can run this. I don't see anything. Same shape of this problem. Is that maybe down to that C11 standard? Like, what is SDCC? Generic star. Does it need to be a generic star first? I think it might be generic star. Oh yeah, I'm also used to using this SFR app syntax. Can I still use that for STM32? I only used that for 8051. I wasn't sure if that worked with other ports. It's all under bar data. Yeah, I'm going to use plenty of this. Like, coming out the campus with keyboard and
Did anyone go to Maker Faire? Anyone out there? This is me talking in real time. I haven't been in many years at this point. I think I went to the first or second one, and then to like one or two others. It was kind of interesting. It just got really big and really, like, I don't know, like the things that got hard about it got worse, and the things that got nice about it got harder to find. So, yeah, but I was seeing a lot of people seem to be enjoying it. I don't know. The whole maker movement is pretty weird, though. It's kind of this, like, I don't know, it's like a weird brand, right? I think that coffee is still too hot.
anything. It's all under bar data. Yeah, I'm going to use plenty of this. Like, coming out the campus with keyboard and Can we leave out this podcast now? I'm thinking about having so many questions. That's interesting. I'm using this sort of anymore. It's unclear whether that's good or not. Oh yeah, and we're setting the app mode flag based on reading a GPIO, so I assume that the firmware would just kind of start to malfunction if you change that GPIO strap, because it looks like the other app mode isn't really implemented. So this sounds like push should be like close to the top stack. That's going to be, I think, the pin, and this first one might be a mode. I don't know why that would be different. Oh, it initializes it, so it starts out.
What am I doing now? the default options. Wait. What? This is 8051 code. How did we get back to 8051? Oh. Not all the default options. Okay, what was going on with this code earlier? I don't see anything. Null. This code's not terrible. That looks like STM8 code. I was worried that that was going to be 8051 also, but I don't see anything obviously wrong with that. I think I must have... Did I run that on the command line and then later just write a makefile that was wrong? Yes, that's exactly what I did. So right there, that was the correct command, and then later I made a makefile and briefly had that generating 8051 code instead. Underbar data. I guess they couldn't have just used plain old data because that's like common enough. I don't see anything. I guess they couldn't have just used plain old data because that's like common enough that you can't just reserve that as a keyword and expect that you can use the opposite. I'm thinking about having selecting expressions. That's interesting. Our using those source technically anymore. It's unclear if that's good or not. What? Wait. What? This is safety code. How do you do one? Oh. Not all the options. I feel like I'm going around in circles. You and me both. Yeah, this is back to what we were seeing before. I mean, I think we've already seen this code work. Yes. I guess it wanted an IHX file by default. That's interesting. It'll preset also file. I wanted to get a little bit of footage of this makefile. What's up? Yeah, so I'm not seeing anything. Yeah, I mean, is there like a watchdog maybe, or some kind of oscillator I've got to set up? We could look a little closer at the setup code in the original firmware maybe. I would prefer to edit out this entire detour for in the interest of time, but if I do have to keep some of it in, that fragment might be useful. Yeah, I mean, is there like a watchdog maybe? I don't see anything. Yeah, I mean, this code's not terrible so far. Let's see if we can run this. Yeah, I mean, is there like a watchdog maybe, or I'll figure this out. Look at the setup code. Later, I've got to set up. We'll get closer at the setup code in the original firmware, maybe. Oh, my fingers not having keyboard stuff here. That would be a good place to put like a hardware in it. This looks like GPIO in it. And this is probably where we're setting up GPIO directions. yeah, and we're setting the app mode flag based on reading a GPIO, so I assume that the firmware would just kind of start to malfunction if you change that GPIO strap, because it looks like that mode's going to be implemented. Oh, what's on here? So this second push, which would be like closer to the top of the stack, that's going to be, I think, the pin, and then this first one might be a mode. Oh, that one would be different. Oh, maybe this initializes it so that it starts out lit, because maybe this is the default. And this is 3 of the LEDs, whereas it looks 80. I spent way longer actually taking apart the original firmware than anyone actually wants to watch. I assume some people enjoy the streams, but it's usually not something that is going to hold like 100% of your attention. But then again, maybe neither is a 20-minute YouTube video. If I was understanding that, it looked like they initialized 3 of the LEDs, but not the 4th, which is really weird. It doesn't make any sense to me. This is that other function which I wasn't sure was GPIO related. The other thing that makes this a lot harder to deal with on stream is I'm really used to being able to just like spread out documentation everywhere, and I feel like I'm doing this all through like a little submarine porthole or something when I'm in 1080p on stream. So what is that? +4. This is a recursive submarine porthole. This is like basically an Arduino style kind of pin mode thing, except more GPIO port flavored. Like I think the numbers that you give this are basically a distillation of the pin's like configuration. Like is it? Yeah. I'm kind of curious. So James says they'd like to see a video about tearing apart the firmware of something at this sort of level, but they don't think this is a particularly good project for building it out of. I agree, although I'm kind of curious what your reasoning is. I think, yeah, this project, the product here that I'm starting with, the USB switcher, seems like it was very hastily assembled out of whatever parts were convenient, which is not necessarily what you want to be learning from. But, yeah, I'm curious. I'm sure there are multiple reasons not to do it that way. Yeah, is there like a watchdog maybe, or something else I gotta look at the subcode already. This is like basically an Arduino style pin mode thing, except what you get. Like I think the numbers that you give this are basically a distillation of the pin's like configuration. Like is it drain, is it input, is it output, is it push-pull? We can follow this here exactly what that means. That's extremely necessary. It looks like this is kind of like separate accessing GPIO. We could poke around with the oscope to see if any of the pins are toggling when we do this, in case maybe the pin is wrong. We might as well just do this all 4 of the pins. Maybe, or I'll figure this out. I'll look at the subcode already. Might as well just do this all 4 of the pins. I don't know if I'm going to want that. I wonder why the original firmware wasn't using these bset and bres instructions. Maybe because it wasn't inlining. So I'm try resetting the target here by plugging everything, plugging one of the power leads back in. Is there a watchdog? I feel like even if there was a watchdog, I would be seeing this blink. We could try getting the in-circuit debugger working. Am I using the wrong port? Nicholas says the LEDs are on port C, not D. I think that was the problem. I was mostly going by this base address, 5000F. Oh, how did I get that wrong? How did I get that wrong? You're totally right, I'm just making bad mistakes. The LED port is indeed 5000A. Yeah, thanks. I just missed that. I think I'm gonna edit out that entire section. Oh, no, dim. Yay, thank you. Let's add a temporary delay here. thing is, the NOP isn't even necessary here. Just an empty as and volatile should keep the loop from being optimized out. Fill that with delays, all cheesy like. Or is indeed 5000A. Fill that with delays, all cheesy like. Really? That GC thing? Get there. How'd that work here? Yeah, I keep forgetting how bad this C compiler is. I mean, in this case, it's just a GCC, isn't it? It doesn't support, but. Alright, fine. Wow, okay. Yay. That's better. How bad this compiler is. I mean, in this case, it's just GCC, it doesn't support it. Wow. Wow, okay. Yay. That's better. We've reprogrammed it. We've reprogrammed it. Oh my gosh, this is one of those streams where I feel like I can barely think. Christian says that's an issue. Yeah, I mean, that's a good point, that with this firmware reverse engineering, we didn't really learn anything other than what we could have found just by tracing the circuit. I was looking mostly to see if there was any interesting stuff hidden in there, and everything that was in there was basically just not working. It was just like a bunch of vestigial stuff from other projects. So yeah, that's like one argument for pulling it out into a separate video, is it doesn't really impact the storyline of the main thing at all. But yeah, like I mean, that's the thing, this footage is not really great at being just a video about firmware reverse engineering. It's not really great at supporting the whole project's storyline. Do I just throw it away? It seems like an interesting video on its own, but it's not like the best thing that it could be. It's just an okay thing. And this is part of why this demotivates me so much. It's like, no, everything is just kind of okay. Nothing can be good anymore. Just drowning in piles of kind of okay footage. Yay. That's better. We've reprogrammed it. Christian says exactly what structure work. I mean, you probably start right. We were just there, and I was feeling we've got it working. I can go back and make it pretty, but like, yeah, obviously if this was a real C compiler, we could do that. It's just here I am balancing the fact that I don't know what the C compiler supports, and I don't know what's wrong with my program with just like wanting to actually get it to the blinking point. So we've got it blinking. I can put this back the way it was. Edit out the peanut gallery. Usually when people are asking me, why aren't you doing the obvious things? I mean, if we're basically just relying on the inlining here to make the code nice, we could also make this take a boolean. It would also be slightly nice to have a way of specifying a port and a pin in one data structure. There are a lot of different ways to approach that problem. I've seen people like encode the two values into 132 value at compile time. I've seen like lexical approaches where there's a pound define that expands into two parameters with a comma token in the middle. Like, I don't know what to bother with right now because this whole program is going to be so simple. It's great, I like that for functions, but not for like loops or structs. Let's go back to only one LED for a sec. Actually, let's abstract this a little more.
Oh, James, I'm not saying you're demotivating. I can do the demotivating all by myself. I'm not blaming anybody else.
I'm getting annoyed by trailing white space even when I can't see them. I know you can solve things happen with changes, not here. That's the other thing people assume, which is kind of annoying. It's like, oh, I do the thing. I'm like, I do things sometimes, but I'm not doing it right now. Go away. Is this too fancy for SDCC? Will its optimizer give us something awful? This is me just pushing my luck with SDCC. We'll turn that into an and. Let's find out. Oh yeah, thank you. Okay, so set channel. I mean, this could be worse. I'm not really concerned with code size, just given how little we have to do and how much space we have. Seems alright. STCC is not smart enough for that. I don't want to do an integer modulo right there.
I don't know if anybody else is gonna find that funny.
I actually just want to do that. I actually just want to do that, which a lot of compilers could figure out on their own, but SDCC is not that great. Yeah, that's much better. Oh, I got the polarity wrong, but now we've basically got to accept the wrong polarity. Okay, that's almost right. Let's just negate that.
Some of these bits are not really interesting, but I'm keeping them because I might be able to use them to smooth out the edit in a later stage
Okay,
of this.
that's almost right. Let's just negate that. I think figure out on their own, but SDCC is not that great. Okay, that's almost right. Let's just negate that. Yay! Well, this is getting pretty close to being something that's useful. We would need to actually change the switcher channel, and then most importantly, we would want to wait for a serial character over, some kind of input.
Yeah,
I'm assuming that what we want to do is set up the UART for like $2,400 or $9,600 or something simple like that, and then just look for characters and switch that.
Yeah, I think I slept on it and decided not to do it the serial way, but for this whole filming day, I was assuming it was going to be serial.
Let's just negate that. Gosh, it's been a long stream and I'm feeling kind of low on energy, so it's tempting to call it a break now and come back for part 2, but it's also tempting to keep going. You know how that is. Gosh, it's like fine. Well, maybe what we want to do is slow this down a lot just so that we can actually tell if the USB switching is working, and then have the USB switching. There's an extra one, it does seem to start on the leftmost channel, which seems to be the first one. Alright, I need another quick restroom break. We'll be right back. Twitch chat says C is kind of hot. I don't think it could keep the room warm. I mean, it kind of does. I guess a lot of C code is keeping the room warmer than it otherwise would be, but unfortunately the amount of draft we have here is a little higher relative to the amount of video encoding. Oh, man, I don't think I'm going to find a better stopping point in this, so it's kind of tempting to call it a stream right here, and then we can come back to this. I don't got time to do that. But, can we at least get the USB switcher switching? Because that would be fun. This isn't really just Blink anymore, is it? Yeah, right, I need a warmer blanket like Tuco has. Actually, I wonder if the pilot light went out. I should go check that.
This was in February.
Pilot light's fine. The thermostat was just set pretty low. Gosh, if it wasn't streaming, I would be sitting right over here now. Hey, Tuco, not this. Dude.
Wow.
Oh gosh, well, this was going to be at the little landscape before to go. Sorry, trying to get on my nose. Oh. I just get the switching channels. No. 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 No, no.
Oh gosh, things are really going off the rails here. How much of this is there? Okay, what am I doing to the computer, and do I need footage of that? Just fussing with this LED code right now. All Tuco's driving me nuts.
No. No.
I'm just renaming it in the makefile.
No, Tuco, leave that. No.
Oh gosh, Tuco.
Dude. No.
Yeah. Okay, so for setting the channel, just to keep the numbering consistent.
Oh, Tuco, please. Oh, Tuco, please. Dude. Keep all the wires open. None of these wires. So the way this does it is kind of weird. I think I might just want to treat these as a most significant and least significant bit of the channel. Duke. The way this does it is kind of weird. I think I might just want to treat these as a most significant and least significant bit of the channel. Duke. I really hate being interrupted. I really don't like it. Wait. The voltage. You know, maybe they don't switch both of the... Maybe there's a glitch they're avoiding getting it this way, actually. Because if you were to set the... Well... No, this causes a glitch. I can't think of any advantage to doing it the way the original firmware does it. Does that armor full video thing? I can't think of any advantage to doing it the way the original firmware does it. By glitch in this case, I mean that in the digital logic state is not file state. Which is not optimal, really, but I think it matters. This is basically a anyway. USB are noisy and unreliable during a hot plug. Anyway. So port 5005 bit 10. What was it? And nice bit 5 was. So port 5005 bit 10 is one of the least significant bits. Port 5005 is going to be... The other least significant bit is port 20 on the same port. And the other least significant bit is port 20 on that same port. Zuko, what are you doing? How are you even standing there? Oh my gosh. It's actually kind of nice when I'm having a bad day. I can watch my past self having a worse day. And the next one's 4. Port F. Tico, no! I attempted to stretch the meaning of Boolean right there, but I think it's a little bit more fair to do that. Do I want that? Oh, let's save this and throw it away later. I attempted to stretch the meaning of Boolean right there, but I think it's a little bit more fair to do that. So we have delay, set channel, we're setting channels, and then I'm not doing the original format, I'm just reading. Let's try that. So we have delay, set channel, which sets the LED and the USB channels, and then slash so in the LED lights that's true, which sets the LED lights that's set channel set channel, which sets the LED and the USB channels. And then I'm not doing it the way the original firmware does it. I'm just treating both of these pins as least significant bit and this one as most significant bit, which seems fine. I can't think of a reason why that wouldn't work. Okay. So there are a couple ways we could figure out if this is working. We could just try to use it as a USB switch. Maybe we're going to try first. Oh, that's interesting. When I plug this in, it looks like a micro reset. Tuco, what are you doing? Stop that. What are you doing? What was he doing? Oh. Tuco, what are you doing? Stop that. What are you doing? Is he biting at one of those cables? What was he doing? Either it's not working or it's switching too fast. Let's make it switch a lot slower. I don't see it working. Oh, I didn't initialize the other IOs. That would be a reason for it not to work. And this one is most significant, which seems fine. Didn't work. I don't see it working. Oh, that was working for just a second. Oh, that was working for just a second till it switched channels. Oh yeah. Plug in the other computers and let me see if I can actually see it cycle between all the computers. Dude, it's making me nervous just looking at every wire over there. Okay, fishbowl. Workstation is asleep. Here we go. Okay, now on steering box. Now on tablet. Cool. Now on fishbowl again. This machine's also switching. This workstation doesn't work where I have to parse all the monitors. The monitors themselves crash in like 7. Very strange. I had problems with those monitors on machines, so I just do glitch. And then fishbowl. There it is. Yeah, that's computer 2. Well, that checks out, so I know. This is a little folder from the There it is. Yep, that's computer number 2. Well, that checks out. So I'm now cycling through all 4 USB channels with the LEDs in sync, and it seems. There it is. Yep, that's computer number 2. Well, that checks out. So I'm now cycling through all 4 USB channels with the LEDs in sync, and it seems to be working. The only piece left really is to initialize the UART and wait for UART characters. We are so close to that. I think I should just get the.
No.
It's too close, right? And it seems to be working. I'm glad I at least took a breath right there. The only piece left really is to initialize the UART and wait for UART characters. We are so close to that. I think I should just get there.
No, you're not even doing that. You're not even doing that.
Well, I guess I'm gonna switch this out until I have real input. Otherwise, just cycling the entire time. But... if I'm gonna test this at all,
I'm always going backwards over and it's like
is in sync, and it seems to be working. If I'm going to test this at all, I really do need, I need to modify this word to actually give it a serial input. Well, maybe this is a good stopping point. I don't know. I've been streaming for a while, and this would be a pretty nice point to start another stream at, maybe. Because we've got basically the tedious part done, I hope, maybe. Then again, it would also be a good starting point to just have something we can send characters to and do, like, calf or...
Yeah. Wrap it up.
Yeah, I think I'm gonna call it a night. I feel like I've been kind of extending myself for a while already, so I might as well stop it. But I should do it. Maybe play with him and compete with each other. Well, cool. I don't know where too much about GitHub just yet. Well, cool. I don't know if I'm gonna worry too much about putting this up on GitHub just yet, because I might wait until the project is slightly more usable. This is a basic firmware that just switches channels on this switcher using the existing micro, so that's more than I expected to have done on this stream. Yeah, I don't know if I was gonna put this in GitHub. What would I call it? The board seems to be Ugreen branded, but I don't know if that's actually who made the firmware. I don't know. I'll probably worry about that some other time. Anyway, I think I'm going to wrap this up here, and we'll come back to this project soon, because I do actually need this to stream. Like, this is part of my infrastructure here, so I need to do something with it, either put it back to normal or finish it. So I think we'll probably have to finish it at this point, or put it back to normal, but it's so close to doing what I want that we might as well actually get there. So yeah, we've got basically everything we need to build a very, very simple firmware for this, which just sets the channel and does... Well, we've selected it's just like we need to build a very, very basically everything. So yeah, we've got basically everything we need to build a very simple firmware for this, which just cycling through all 4 USB channels with the LEDs in sync, and it seems to be working. So yeah, we've got basically everything we need to build a very, very simple firmware for this, which just sets the channel and does whatever else we want, which I think what we want is to read some data from serial, but yeah, we can do that next time. A very, very simple firmware for this, which just sets the channel and does whatever else we want. And does whatever else we want, which I think what we can get. Oops, no, we've selected whatever else we want. Oops. I think what we want is to read some data from serial, but yeah, maybe next time. Say something for people more, not to burn out. You know, maybe that's more for myself than for you, but yeah. Let's try to at least put this project somewhere where Tuco is not going to lose all these between now and next time. I think I want to give it a case. I do want to put it in screws. I don't want the case that has spot for sale, but. Oh, a little box for all these goods. This is a bit of another kind of random impromptu stream, but I guess a lot of them are. Yeah, let me know what you think. This little mini project. I think once I edit out all the kind of like faffing about with text editors and actually get to just the substance of the project, it can be a pretty short video, so that'd be nice. Well, yeah. I guess I should unplug this so I'm not just like USB hot plugging all day. Yeah, that's the thing. Thanks for stopping by, and a special thanks to everyone who supports the channel. Everyone who sends in hardware for us to work on, and everyone who supports the channel on Patreon monthly. Like, you're the reason why we can just keep doing this. So if you like this content and you want to see this continue, just kicking in a couple bucks a month on Patreon is really the best way to do that. It's, you know, there's like ups and downs about the platform, but for better or for worse, it's a platform that you know, is kind of enabling something that I don't think I can manage otherwise. So, you know, I appreciate help in pretty much any form, but you know, my patrons have been just like an especially kind of stable source of income right now. So it's been nice to have that as I do my best to try to bring you some kind of video content that you'll enjoy. And as always, I mean, I'm doing this for all of you, so if there's some feedback you have, I am generally pretty interested, so let me know in whatever format you prefer. But yeah, I'll try to stay warm and maybe get some pizza. I'll see you all next time, and we'll get this project doing something a little more useful. Thanks, everyone. Happy hacking. Is Tuco here? Oh yeah, I was gonna like give you a little bit of cat on the way out. The camera wasn't quite lined up. He's back on the heating pad. Happy hacking, folks. Oh yeah, it's actually kind of hard for me to turn off the stream when I don't have my USB switcher doing its usual thing. Which USB cable do I plug where to make this happen? Hello? Why can't I play? Which USB cable do I wear this time? Oh, there we go. Giant pizza as a blanket. Yeah, that sounds great, actually. A little greasy, but warm. Right. See you later. Happy hacking, everyone. Oh, so now I've got this little recording, and why is it red? Usually, I thought I had a slight speed conversion. Yeah, why is it at 99.99%? Doesn't appear to have changed anything. But I set it to 50% and then back to 100. These boxes are one of my least favorite UIs on any platform. You cannot type 100% because 1% is not a legal value and it error checks after every single keystroke. So simply because 1% is not legal, I cannot actually type 100%. I could maybe manipulate the number to a legal one by adding and removing digits, but I don't want to have to play that puzzle every time I change a clip speed. Jesus, Adobe. Why do you make me do this? I'm okay. I'm okay. It's still 99%. I'd be more worried about this if I thought this was going to be a more important clip, but I don't know if this is one I actually need. Oh gosh. Can I reinsert it? I guess that fixed it. Hi. For this, which just sets the channel and does whatever else we want. So yeah, if you're just joining us, this is still kind of early in the editing process for this next video, but it's going. There's so many steps. Like I end up with these raw files from every filming day, which look like this. So I've just got a bunch of separate files from the camera, and then one file from the stream. Oof. Source monitor. That's a lot of what you're seeing is this single stream recording. But these items down here are not actually just the stream recording. These are multi-camera sequences. So if I open up any of these in the timeline, you can see they're actually already pasted together and aligned. So that was something I already did previously. It's a semi-automated process. There's still more manual to it than I'd like. So yeah, this shows you all the tiny little clips that my camera ends up recording. And this time there's a separate microscope recording track. No, we have select right upset net on edge that sets the channel and does whatever else we want. Hello, hello, getting the bits flowing. I had a pretty long stream yesterday, and this one's getting started later than usual, and I might have other stuff to do pretty soon, so this one might actually be kind of short, but had some stuff that I've been itching to share in continuation of the
that's
stream,
right.
so hopefully this will be kind of interesting.
I think I had plans with someone really shortly after I started this stream, so it ended up being really short.
This is continuing on just a little mini project that was kind of utilitarian, where I needed to modify this USB switch that I usually use in streaming structures so I can switch between channels without pressing this party button quite so much. So just doing my usual checks to see if we're streaming. Looks like you're live on YouTube, you're live on Twitch. How's everybody doing this Friday? Oh, the cat camera's not even turned on right now. Oh no, grumpy, I'm sorry. Okay, yes, I'm here live on Twitch, books and all. Thanks, folks. Cool. Gosh, we're back from 19 minutes. Like, where's my stream, guys?
Wearing the same thrift store sweater. This thing is way too big for me, but at least I don't care if Tuco destroys it.
These are actually very old. I remember buying them from the bargain bin at a electronic circle shop back in Colorado many years ago. But they're interesting, they're kind of tall.
Oh, I'm introducing the buttons. This part's actually maybe important.
Yeah, good evening, everyone. How are y'all doing? So I used to think it was really weird that my folks would say y'all all the time, but now I find myself doing it more often.
Yeah.
Alright. Got some cute little buttons here. These are actually very old.
We want. Got some cute little buttons here. These are actually very old. Old. I remember buying them from a bar.
The channel and does whatever else we want. Got some cute little buttons here. These are actually very old. I remember buying them from a bargain bin at an electronic surplus shop back in Denver, Colorado, many years ago. But they're interesting. They're kind of tall. They don't have any kind of tactile click, which some people might find frustrating, but I actually find this sort of continuously springy feel pretty satisfying. And this might be nice for switching channels during a live stream. This might be nice for switching channels during a live stream because it doesn't make much noise. Whereas this one, it actually doesn't make as much noise now that I have it outside the enclosure. Whereas this one, it actually doesn't make as much noise now that I have it outside the enclosure, but it has a big clacky tactile switch. It has a big, it has a big clacky tactile switch. You see that?
Yeah, we see that. Thanks.
You might also notice why I get frustrated by this a lot. If I'm, for example, trying to switch it from channel 1 to channel... You might also notice why I get frustrated by this a lot. If I'm...
I think a lot of this is going to end up back at the beginning. That's justification for all this other stuff. That's fine. It's a future editing pass.
For example, trying to switch it from channel 1 to channel 4, I might like click it like 3 times or something. But if I just like click it 3 times, it might go 3 times, it might go 2, it might go 1. The button debalancing on this is very unreliable. So yeah, this has been a very frustrating user interface, even though the actual USB switch part of it works fine. So I just opened it up kind of on a whim on the last stream to see if we could improve it. This has been a very frustrating user interface, even though the actual USB switch part of it works fine. So I just opened it up kind of on a whim on the last stream to see if we could improve it. The other reason to do this now, you know, because like there's plenty of projects, like why do this now? I was just rearranging some of the stuff on this part of the shop, and I kind of made the problem of the USB wiring being further from the user interface part to the desk kind of worse. So for this USB extension cords all over the place, much more than I would normally prefer to. So it would be great if I could both less frustrating and make it remote, so that I can actually user interface part to the desk kind of worse. So for this to work at all now, I'm running USB extension cords all over the place, much more than I would normally prefer to. So it would be great if I could both make the user interface for this less frustrating and make it remote, so that I can actually have the user interface be separate from the USB switcher. So that's really what I want to do, is I want to USB switch part of it works fine. So I just opened it up kind of on a whim on the last stream to see if we could do this now, you know, because like there's plenty of projects, like why do this now? I was just rearranging some of the stuff on this part of the shop, and I kind of made the problem of the USB wiring being further from the user interface part to the desk kind of worse. So for this to work at all, now I'm running USB extension cords all over the place, much more than I would normally prefer to. So it would be great if I could both make the user interface for this less frustrating and make it remote, so that I can actually have the user interface be separate from the USB switcher. So that is really verbose. I don't think I'm actually going to keep that, but I need to at least explain something similar in the final video. Really what I want to do is I want to modify this so that I can have a separate little user interface box, which is maybe something that's tiny and I can just like stick right above my keyboard, and then I can just press these buttons and go directly to the channel that I want, and maybe even see which channel I'm on here. So that would be cool. I might also use that audio on top of other video. I don't know. I might also re-record that. And there are a lot of ways to do that. You know, I mean, like the simplest thing to do would be to just keep using a pile of USB extension cords, because that works, and then just keep this box as my user interface, but fix the firmware so that the debouncing doesn't suck so much, and I can use multiple buttons maybe. So that would be one option. This switcher has a feature I'm not using where it tries to automatically switch to a channel when that channel is plugged in, checking the USB cables. I don't actually want that feature, so if I want to sacrifice that feature, that saves me 4 GB with the use whatever I want. So that would be an easy way to add 4 buttons. And in fact, I don't think the software would quite the way I want if I just like use it as is and add buttons and treat those buttons as like voltage detecting inputs, but it would be close. So that would be one approach, is keep these firmware mostly modified and just treat the user interface as voltage detecting inputs. But I think I want to do something slightly nicer and actually remote user interface. Could be just very much button or using a pretty heavy. I wanted to use a pretty small wire. And in fact, I don't think the software would quite if I just like use it as is and add buttons and treat those buttons as like voltage detect inputs, but it would be close. So like that would be one approach, is, you know, keep the existing firmware mostly unmodified and just treat the new user interface as voltage detect inputs. But I think I want to do something slightly nicer and have a actually remote user interface. Could do that just by running a bunch of nubbing in over, and then I can just press these buttons and go directly to the channel that I want, and maybe even see which channel I'm on here. So that would be cool. I think I want to do something slightly nicer and have a actually remote user interface. Could do that just by running a bunch of separate wires for each button, or by using a pretty heavy cable, but I also wanted to use a pretty small wire. So, oh, is there no audio? Sorry. Actually, some useful audio. Might be listening to some audio. Although I might be basically out of time soon anyway. Well, let me see if I can get through this little recap, because I've got some recap momentum to just kind of talk about where I'm at. And maybe instead of like a work stream, this will be more of just like an explanation stream, and we can do the actual work like tomorrow or whatever. So anyway, so yeah, I wanted to take this USB switcher that I've been using already for these streams to switch between several different computers. The way I'm using these channels is I have a couple different workstations that I use for demos. There's one that uses demos, so I use one, like anything for scientific purposes. And there's one for sort of chat monitor tablets, and there's one for chat monitor tablet, and then one for the actual stream machine, where you use what the settings are. So at the end of last stream, we actually got progress. I got a point of pulling from off this standard STM, an STM8 debug interface. So at the end of last stream, we actually made a lot of progress and got to the point of pulling firmware off of this. It turns out there's just a standard STM, an STM8 debug interface enabled. You can read flash memory. There's no protection enabled or whatever. There were some enticing clues in the firmware. It looks like both the circuit board and the firmware have vestiges of infrared remote control support. It was So at the end of last stream, we actually made a lot of progress and got to the point of pulling firmware off of this. It turns out there's just a standard STM, an STM8 debug interface enabled. You can read flash memory. So at the end of last stream, we actually made a lot of progress and got to the point of pulling firmware off of this. It turns out there's just a standard STM, an STM8 debug interface enabled. You can read flash memory. There's no protection enabled or whatever. An STM8 debug interface just a standard pulling firmware off of this. It turns out there's just a standard ST. Error. So at the end of last stream, we actually made a lot of progress and got to the point of pulling firmware off of this. It turns out there's of this. Yeah, well, a pretty small wire. It turns out there's just a standard STM, an STM8 debug interface enabled. You can read flash memory. There's no protection enabled or whatever. There was there were some enticing clues in the firmware. There were some enticing clues in the firmware. It looks like both the circuit board and the firmware have vestiges of infrared remote control support. So So it seemed like, oh, maybe that's an existing serial interface. Maybe we just hook something up to the IR remote control interface, either an actual IR receiver or just use that as serial input. But actually, um, um, but actually, it's depressingly, that seems to be vestigial from some copy pasta from what appears to be like a video switch firmware that they started with. And then, yeah, so the video switch firmware still has like strings and code left over from like HDMI and like YPDP appears to be like a video switch firmware that they started with. And then, yeah, started with. And then, yeah, so the video switch firmware still has like strings and code left over from like HDMI and like YPDPR inputs and stuff like that. But if you actually trace through the code, which we did in the last stream, and we were tracing through the code just in a text editor because I don't. There are a lot of tools that do STM8 disassembly, so we found just like a plain old disassembler and just did old school reverse engineering in a text editor, and that was fine. And we traced through that IR code and found out what commands on the remote to individual like functions in the software, but then it just did nothing with them. It was like a switch statement that had some debug code but nothing else. So it was vestiges of some infrared remote processing, but nothing actually useful. So that's kind of a dead end. Kind of a similar story with the serial port. We found a bunch of debug printfs, but the actual like printf function was an empty stub, and nothing actually touched the UART except for some code which seemed to just turn it off, and then nothing was calling that function. So yeah, just some vestigial code that's useful. And the code was not good. It's just like did stuff that seemed like they just did the minimum amount of work necessary to make it work, which is not surprising. But it just means that there's not a lot there that's really worth building on, probably. So yeah, at the end of the last string, we had that kind of figured out and got to the point of writing sort of the hello world firmware for this board, which could just cycle through the inputs. And so, like right now, it's back to running the original firmware. I just loaded the original firmware on here just so that I could use it again. But if I flash the firmware that we've got here, so this is flashing the current work in progress firmware. And it just went all Here's not great. This is SDCC. There's no DC or import processor. So it's clear solution to SDCC. It's basically we're still using. It's not great, but it's like you need to learn this just to express part. So yeah, I got this little scaffold. So at this point, actually, I'm going to switch my user input back to a hardware function. Bypass the switch. Otherwise, it's going to be silly. So I think I can work with that machine now. Bypass the switch. We need this. This is the firmware so far. It's written in plain C without any libraries, so just ping on GPIO. Somebody might have header files for STM8, but I haven't looked for open source ones, so I couldn't even find the document that listed the base addresses for all the GPIOs, which is, and then we don't need this window open, that's just confusing. So yeah. This is the firmware so far. It's written in plain C without any libraries, so it's just pinging on GPIO registers directly. Some libraries, so it's just here. Well, we C without any libraries, so it's just pinging on GPIO registers directly. Somebody might have Somebody might have header files for STM8 plain C without any libraries. Somebody might have header files for Somebody might have header files for STM8, but I haven't looked for open source ones, so I couldn't even find the document that listed the base addresses for all the GPIOs, which is, and then of course I was doing this addresses for all the GPIOs, which but I haven't looked. It's like when I was already tired at the end of the stream and like couldn't multiply and divide, so I was calculating the wrong addresses in all the GPIO registers. But I have GPIO lines. These are hard code, but we have some functions you can call static channels. How this works? Just a little hard code loop and this channels. So the last stream, I was planning on adding serial with this. Maybe you just have like 3.3 volt or 5 volt serial. It's like 9600 baud or even like 300 baud or something just for signal integrity. And maybe you just send in ASCII characters to those channels. But thinking about what I wanted on the other end of that, kind of between then and now, I don't know that I really want to put like an entire microcontroller on the other side. Like I could make my own little board with a little 8-pin AVR, and that would be pretty small and economical. I could use a trinket, which is kind of without any libraries. Thinking about what I wanted on the other end of that, kind of between then and now, I don't know that I really want to put like an entire microcontroller on the other side. Like I could make my own little board with a little 8-pin AVR, and that would be pretty small and economical. I could use a trinket, which is kind of the next best thing without having to design a custom board for that. But the trinket, basically using an 8-pin chip doesn't really give enough IO. Basically, use that to get all of your back. So that's what we're doing. We could use micro pins. Dip package AVRs. We could use. Just complicated. Like I wanted to build a project, like designing a separate board, running 2 firmwares. So I started thinking, really cool if I could do this without a separate microcontroller. Just have a fun this and maybe. So then I was thinking, well, what could I do with a small cable since it's convenient? So it'd be really nice to run something like cable. 3 wires. I don't necessarily have to use them as ground and 2 signals. I could just use them as 3 wires. So that got me thinking about what I could do with Charlie plexing. So yeah, I'm a little rushed for time, so I won't draw like a new diagram for this maybe, but. drew this like tiny sticky note diagram on this. I was thinking about Charlie plexing as a matrix. There are
I'm gonna redo all of this.
tiny sticky note diagram on this. I was thinking about Charlie plexing as a matrix. There are a lot of ways to think about this, but one way you can think about this as is that it's like an LED matrix. It's like any other matrix. Matrix. There are a lot of ways to think about this, but one way you can think about this as is that it's like an LED matrix. It's like any other matrix of like driving LEDs or scanning switches, where you have maybe one set of signals for rows, one set of columns, and instructions and LEDs, and what you set one row, columns, and columns, etc. Charlie plexing is the realization that the rows and columns can be the same pins, basically. And Charlie plexing, that's kind of the way I think about it. It's kind of matrix where rows and columns are physically the same wires, and the diagonal matrix represents all the combinations where you would have the same wires.
Yeah, these unscripted explanations just turn into these big walls of sound that are not useful when I'm editing the edited videos.
It's like any other matrix of like driving LEDs or scanning switches, where you have maybe
So
one
this is
signal
just going to be a stand-in for basically the same thing, but actually scripted and done properly.
or a switch or something, and then you set one row and then read all the columns, you set the next row, read all the columns, etc. There are a lot of variants of this matrix scanning approach. Charlie plexing is the realization that the rows and the columns can Charlie plexing is the realization that the rows and the columns can be the same pins, basically. I mean, there are a lot of ways to think about Charlie plexing, but that's kind of the way I like to think about it. I'm using it. I think about it. And so you can imagine that it's like a matrix where rows and columns are physically the same wires, and the diagonal of that matrix represents all the combinations where you would have the same wires, so you don't have current loop, but everything that's off the diagonal, every square off the diagonal matrix represents a potential current path through that wires. So if you have 3 wires, then you have 6 potential current paths. So traditionally, Charlie plexing LEDs, that would be 6 LEDs, by wiring LED in each of those different combinations indicated by that diagram. You could add switches to that by putting switches combination, one switch series LED, in place of switch series LED. So one way to think about this is we have 6 potential current paths, and we can match those between LEDs, switches, or potential current paths, and we can mix and match those between like LEDs or switches or other circuits. Like one way to think about this is we have 6 potential current paths, and we can mix and match those between like LEDs or switches or other circuits. But that's still not enough, because if I want 4 channels, an indication of what channel is current, I need 8 things. Like I need 4 LEDs and 4 momentary switches. There's some other things I considered, like what if you have LEDs where those same current paths are also used as switches, and you use a normally closed switch in series with the LED, and so you can treat that as a diode and just like scan that like it's a keyboard matrix, or light it like it's an LED. But then when you press it, while you're pressing it, you're kind of breaking that circuit. You might know, yeah, it reminds me of some. Well, the effect would be a little bit like kind of an old school doorbell, where like in those cases, I think when you press the doorbell, they were wired with like a switch and a light bulb in parallel. And so pressing it would short out the light bulb and the light would go out. And this would be similar. Pressing it would disconnect the LED and the light would go out. So it would be a little weird from a UI perspective, where pushing the button, it would momentarily go out, and then when you let go, it would be lit. But I think we can manage that. The trouble with that is that it would require using momentarily only closed switches, which exists. There's not and I can't just pick up any random light switch I find and I want to use it. So our requirements here, if I want something has 4 LEDs, 4 switches, and works with momentary only closed switches, that's a little weird. And so it's like about that, so I'm trying to figure out what we do. I'm not totally sure it works, because I haven't tested this. Works with momentary 4 LEDs, 4 switches, and works with has 4 would require using momentary only closed switches, which exists. Just pick up any random lighted switch out of my junk that I want to use. So my requirements here, so my requirements here, if I want something that uses 3 wires, has 4 LEDs, 4 switches, and works with momentary normally open switches, that starts to look a little weirder. And so I was like racking my brain about that this morning, trying to figure out what we could do. I think I came up with a solution. I'm not totally sure it works, because I haven't tested this, but yeah, that's what we could do. I think I came up with a solution. I'm not totally sure it works, because I haven't tested this, but I have an idea. Oh, here it is. So it's like Charlie plexing. It's like it was. So it's like Charlie plexing, where you're dealing with the current paths that result from 3 wires. I'm using 4 of those current paths for LEDs, but then those other 2 current paths, which I'm selecting here using just whatever diode. I put in a 1 in 914 in the schematic because that was easy in KiCad, but it's probably just any diode that I pick out of my jump in. I might use like a high power diode just because I have a bunch of those. So just whatever diode. So then it would be pretty straightforward here to just put one switch there. Now you've got 4 LEDs and 2 switches.
Oh, this audio is so noisy.
But I want 2 more switches. So
even if the explanation was succinct, I wouldn't really want to use it.
Idea to, at this point you could imagine using all sorts.
I think my roommate was putting away groceries or something.
Has 4 LEDs, 4 switches, and works with momentary normally open switches. That starts to look a little weirder. And so I was like racking my brain about that this morning, trying to figure out what we could do. I think I came up with a solution. I'm not totally sure it works, because I haven't tested this, but I have an idea. It's like Charlie plexing, where you're dealing with the current paths that result from 3 wires. I'm using 4 of those current paths for LEDs, but then those other 2 current paths, which I'm selecting here using just whatever diode. I put in a 1 in 914 in the schematic because that was easy in KiCad. Selecting here using just whatever diode. I put in a 1 in 14 in the schematic because that was easy in KiCad. It's probably just any diode that I pick out of my jump in. I might use like a high power diode just because I have a bunch of those.
Don't want to hear about your
whatever
diodes.
diode. I put in a 1 in 914 in the schematic because that was easy in KiCad, but it's probably just any diode that I pick out of my jump in. I might use like a high power diode just because I have a bunch of those. So just whatever diode. Yeah. So then it would be pretty straightforward here to just put one switch there. In the schematic because that was easy in KiCad, but it would be pretty straightforward here to just put one switch there. Now you've got 4 LEDs and 2 switches, but I want 2 more switches. So I had this idea to, at this point you can imagine. So I had this idea to, at this point you can imagine using all sorts of other sort of like analog properties of this. You could make voltage dividers. Basically you could think of gradations in voltage, current, or time as ways of gradation shader. You could, basically you could imagine using all sorts of but I want 2 more switches. So I had this idea to, at this point you can imagine using all sorts of other sort of like analog properties of this. You could make lots of other sort of like analog properties of analog properties of this. Analog properties of this. You could make voltage dividers. This idea to, at this point you could imagine using all sorts of other sort of like analog properties of this. You could make voltage dividers. You could, basically you could think of make voltage dividers. Properties of this. You could make voltage dividers. Properties of this. You could make voltage dividers. You could, basically you could think of gradation. Basically you could think of sort of like analog properties of this. You could make voltage dividers. You could think of gradations in voltage, current, or time as ways to solve this problem. And this is sort of just an analog low-tech way, to do a serial port almost. It's like a way of having a time-varying signal that conveys information. It's just we need very few different kinds of packets in this setup. So my thought here is one diode, but maybe 2 different switches. One acts like a short circuit. One starts out acting like a short circuit, and then this. So my thought here is one diode, but maybe 2 different switches. One acts like a short circuit. One starts out acting like a short circuit, and then this capacitor charges up, and it starts acting like a voltage source. So the way you would scan this is you would, well, first of all, the way you would scan a normal like button matrix with diodes is you would tri-state the pins you're not using, and then set this to low, and you'd set this to a weak. You would tri-state the tri-state the pin tri-state the pins you're not using, and then set this to low, and you'd set this to a weak pull-up, which this microcontroller does built in. It has like, I think there are like 80 or 100k resistors on the pull-up. A weak pull-up, which this microcontroller does have built in. It has like, I think there are like 80 or 100k resistors on the pull-up. So without any additional hardware, we can just encode. So without any additional hardware, we can just encode, tell this pin to be connected to power supply. Pull up, tell this pin to be connected to power supply through 100k resistor, while we can simultaneously read it as an input. And then we can tell this side to be ground. So you would do this, scan through all the possibilities. Right? So you'll get to be ground. So you would do this, scan through all the possibilities, and notice which ones you read back as high and which ones you read back as low. Because the switch,
I really need to show and not tell for this. I don't think any of this is useful.
And then we can tell this side to be ground. So you would do this, scan through all the possibilities, and notice which ones you read back as high and which ones you read back as low. Because the switch would, when you press it, cause a current path that allows this diode to, you can think of the diode as sort of like, if it's divider, it's sort of like you also have it as some potential to ground. Just close the low side driver microcontroller to ground. This is one diode voltage drop the ground, so like, it's closer to begin with. And then this node here is effectively the same potential that the input side of the board is at. So then you have another resistor connecting like weak spring completely up to positive voltage. But this is this is kind of plugging the voltage down to ground and not allowing it to raise higher than the voltage drop that out. So we read that at 0, where the switch is up, and we're then there's no current path here, and we pull up. Well, it also helps to think out the capacitance in the requiring current to charge up, which is actually what's happening. I find that to be useful for imagining these kinds of circuits. So when you turn on that weak pull up at that instant, you're now charging up that capacitance in the parasitic capacitance of that IO pin, and very quickly it will become high. Not immediately, but probably quickly enough that we don't need any additional delay. So that's like what I would expect from a weak pull up on this side, ground on that side, on one of these regular pins. But then I'm thinking, well, like what if we add some capacitance into the system? So now what if we try to time how long it takes to charge this? Additional delay. So that's like what I would expect from a weak pull up on this side, ground on that side, on one of these regular pins. But then I'm thinking, well, like what if we add some capacitance? Useful for imagining these kinds of circuits. So when you turn on that weak pull up at that instant, you're now charging up that capacitance in the parasitic capacitance of that IO pin, and very quickly it will become high. Not immediately, but probably quickly enough that we don't need any additional delay. So that's like what I would expect from a weak pull up on this side, ground on that side, on one of these regular pins. But then I'm thinking, well, like what if we add some capacitance into the system? That side on one of these regular pins. But then I'm thinking, well, like what if we add some capacitance into the system? So now what if we try to time how long it takes to charge this capacitor? I'm imagining the way this could work is, and I don't actually want to charge it through the weak pull up, I think I want to charge it through a resistance that's a bit more tightly controlled. So on the other side of this, on the other side of the audio cable, I actually have these 220 ohm resistors, which are the same resistors that you want.
Oh, this is getting so complicated because like I'm trying to design this thing thinking about like parasitic capacitance and resistance in the circuit, whereas just trying to explain it in a really basic manner, those are a bit of a distraction. This is also just a big wall of text that I'm probably going to end up editing out completely.
Capacitor in a somewhat more reliable way than just using the weak pull-ups. So maybe you divide the scanning into two phases, like a charge and a discharge, and then you maybe loop that to see how many charge cycles it takes to change the value from a 0 to a 1. Or sorry, not charge and discharge, charge and measure. The thing about this diode is that you can't really discharge through the GPIO pin, so this resistor just constantly discharges it. I'm trying to hit a time scale of maybe like many milliseconds here.
Let's come back to this maybe.
So I won't be sharing the original firmware, but I will share this one that's been written from scratch. Just or sorry, not charge and discharge, charge and measure. The thing about this diode is that you can't really discharge through the GPIO pin, so this resistor just kind of constantly discharges it. I was trying to hit a time scale of maybe like many milliseconds here and a fraction of a millisecond for the charge. So guys, I'm going to save the because I've got to wrap this up. But
I was just really rambling because I was in a hurry and I was also really excited about the circuit.
I was trying to hit a time scale of maybe like many milliseconds here and a fraction of a millisecond for the charge. So guys, I'm going to save the proof of this for next time because I've got to wrap this up. But just kind of want to share what's thinking here. Proof of this for the next stream because I've got to wrap this up. But and then set this to low, and you'd set this to a weak pull-up, and then
current or time as ways to solve this problem.
So my thought here is one diode, but maybe two different switches. One acts like a short circuit. One starts out acting like a short circuit, and then this capacitor charges up and it starts acting like a voltage source. Tri-state the pins you're not using, and then set this to low, and you'd set this to a weak pull-up, and then we can tell this side to be ground. So you would do this, scan through all the possibilities, and notice which ones you read back as high and which ones.
I don't know if there's anything I want to save in here.
I was trying to hit a time scale of maybe like many milliseconds here and a fraction of a millisecond for the charge. So guys, I'm going to save the proof of this for next stream because I've got to wrap this up. But just kind of want to share what I was thinking here. What I like about this is because I'm very simple, passive component circuit. It's easy to mount whatever. With 4 buttons, 4 of these, and then just wire the original controller from there, and that's all. You need to we don't have to add the points to do free. So nice. Alright, well, I think that's basically where I'm going to wrap this up. Keep it short and sweet. This is like the first time stream, so an hour ages. But that's basically where I haven't actually posted this code yet, so I'm going to set up. I don't policy share firmware there for devices for other reasons, so I won't be sharing the original firmware. But I will share this one that's been refreshed based on important stuff. Because we should do everything like this. If you want to just I'll here, but yeah, if you want to just do it, I'll just Alright, I'll see you all next time. Just keep it short and sweet. Thanks everyone who supports channels and objects in the Patreon. Patreon is what helps me swing the full-time video production thing I'm doing here, so if you like that, the best thing you can do to keep going is to just check it out every month. I also really appreciate folks who share my videos with people, folks who really appreciate folks who share what they like about what's in here with me. Because I think one of the things I find on a basis is the first thing I'm doing, figuring out what to focus on. So yeah, I appreciate feedback and I really appreciate some folks who support the channel for so much. And I'll just keep the editing and shopping in the stream. See you later. Bye. Hi, I'm live. Welcome back to the shop, everyone. It's nice today. This will be a bit of a continuation with the project that I described, but didn't get into working on in the research channel today. Sort of a weird way of trying to get a bunch of these sensors on very few wires for a little project here, something for the shop application to use to streams. Got cat here on desk, and noticing a lot of really weird noises. There's some like lower thing on the first. Anyway, though. So You'll be streaming on Twitch, on YouTube, on Twitch. Cool. Let's go ahead and do this. How's something to do for streams? Things ready? Go, so people are on desk. Alright, so this is the USB part. Here we go. Inside it turns out to be pretty simple. It's got these little 10 pin SSD size chips, which seem to be, I think it's one USB server, but the crystal structure is using good day. And I think we're thinking about the USB lanes rather than the individual plus modifiers, so that's on YouTube and on Diode Zone. Cool. Let's go ahead. Tuco looks so peaceful there on the desk, as usual. Alright, so this is the USB switcher we took apart a couple streams ago. Inside it turns out to be pretty simple. It's got these, I think little 10 pin TSSOB size chips, which seem to be, I think it's one USB. But like, first of all, the switch notation is confusing even on a good day, and I think I was thinking about the USB lanes rather than the individual D plus and D minus wires, so that's confusing two different ways. But each of these little chips can switch one USB connection, so a twisted pair, between one or two different destinations. It looks like there's also probably an enable pin that high impedance is, but it doesn't seem like this design uses that at all. And then they have three of those chips forming a little binary tree. And all three of those selectors are connected individually to GPIOs on the microcontroller, even though you could just use them as a 2-bit binary number, which is kind of what my firmware is doing now. Between one or two different destinations. It looks like there's also probably an enable pin that high impedance is, but it doesn't seem like this design uses that at all. And then a good day. And I think I was thinking about the USB lanes rather than the individual D plus and D minus wires, so that's confusing two different ways. But each of these little chips. Oops, charges up and it starts acting like a voltage source. Each of these little chips can switch one USB connection, so a twisted pair, between one or two different destinations. It looks like there's also probably an enable pin that high impedance is, but it doesn't seem like this design uses that at all. And then they have three of those chips forming a design uses that. And then they have three of those chips forming a little binary tree. And all three of those selectors are connected individually to GPIOs on the microcontroller, even though you could just use them as a 2-bit binary number, which is kind of what my firmware is doing now. And then the microcontroller is an STM8. It had a debug port just sitting there, no flash protection or anything. So we read out the firmware and disassembled that. And interesting because there's a lot of weird vestigial functionality and some stuff in there that seems like it might be useful, but upon closer examination, for example, it has like an infrared port, but all the code for the infrared port is kind of vestigial. It doesn't actually go anywhere useful. Like it's detecting some commands from the IR port, and then it's got code to like print debug messages that so it's just that's what use. So instead, it's like a flash microcontroller. Kind of got the boilerplate for that working, and we've got a really basic C program written with SDCC, open source compiler, not using any vendor libraries, just bare metal C programming with SDCC on this STM8 processor using this official STM debug adapter. And that's what's causing it to just cycle through the channels like this, which isn't very useful, but it's proof of concept that the switching is working correctly. So that's where we're at right now. And then on the last stream, I was investigating ways of putting some buttons and LEDs on the end of the wire. And I originally thought, well, maybe we would just use it with a serial port and just have like an 1/8-inch audio jack style thing that maybe provides like current limited power as well as just like a serial input. And then you send it bytes over 9600 baud serial or 300 baud serial or something to switch channels. But I was thinking about that some more, and it just seemed like it was still kind of overcomplicated to have a microcontroller at all on the other side. And I was thinking about maybe there's a way I could do this just using Charlie flexing or some other kind of like passive circuit on the far end to interface the 4 LEDs and 4 buttons. And so I had to do that, which I started on last chance to test. So if it works, we'll have to come up with a new name for it or something. You know, name a new Charlie flexing variant. But I just wanted to recap one way that I thought was useful for thinking about Charlie flexing. So you can imagine, this is like a matrix of different I/O pins that you're using to drive LEDs or read switches or something.
I'm going to redo this explanation, but I want to at least include a little bit of it as a reminder.
So you can imagine US full season that I thought was useful for thinking about Charlie flexing. So imagine this is like So imagine this is like a matrix game. Oops. And it starts acting like a voltage source. Each of these little chips can switch one USB connection, so a twisted pair, between one or two different destinations. And then they have three of those chips forming a little binary tree. So imagine this is like a matrix of different I/O pins that you're using to drive LEDs or read switches or something. If it was a regular matrix drive, you'd have row drive pins and column drive pins, and then maybe set one of the row drive pins, and column drive pins. And then maybe you set one of the row drive pins low, and then set all column drive pins behind pins, and you read them to switch into the next row of pins, using some sort of the way. But Charlie flexing the idea is everything is matrix drive, with the same pins, second row column, and then we do this gap along the diagonals, you can cast current in every same pin. Everything's squared up. But we only really have 6 current paths here. So I think I have an idea for how to do this using 4 of these current paths for LEDs, and then 2 of them for 2 switches each, using a small RC timing. So I think I have an idea for how to do this using 4 of these current paths for LEDs, and then 2 of them for 2 switches each, using a small RC timing circuit. So So we'll get into that in a bit. I also wanted to mention another kind of weird idea I had. I don't know if I'm going to bother testing this on the stream, but if you wanted to, say, have an arbitrary number of LEDs and an arbitrary number of buttons without a lot of circuitry or firmware or custom fabrication or anything, on very few wires, I was thinking, well, what if you use neopixels, like WS2811 style LEDs? So this box diagram on the left would kind of represent a string of neopixels, where each square here is a neopixel with data input on the top, data output on the bottom, and then power and ground on the sides. So you've got a string of data going down. Normally that's all you've got. But then let's say you add a bunch of buttons that act as taps. So when the button is pressed, you're sampling the data signal from a particular point, either the input between the first two LEDs, between the next two, etc. So
I don't know what to do with this idea, other than throw it away, because it's kind of weird, but could maybe turn into another interesting video, perhaps.
LEDs, you could have up to n+1 switches this way. As drawn, the way this would work is you would maybe have like pull up or pull down, so you could sense the steady state when there's no button pressed, and then if there is a button pressed, you would have to be refreshing the LEDs quickly enough that while the button is pressed, you could sample the refresh pattern over this wire and then determine via one of many different mechanisms. You know, you could run like a full correlation detector on the waveforms, but you could also just look for the reset pulse between frames. And by looking at the timing of that, you could figure out how many LEDs the whole signal has gone through by the time the switch was tapping it off. So that could be interesting. Gnarly plexing. Yeah, that's pretty good. Yeah, I was thinking, I mean, Charlie plexing was named after the person who invented it. I don't know if I want to name something after myself, but I could name something after my cat, so I'd be happy to call it Tuchel plexing. But yeah, I don't know. So there's this neopixel kind of idea. Can't tell if the fans on the rack are louder than usual, or if it's just me. I think I'm going to use right away, but I'll hold this for later maybe. Share it with all of you even. But yeah, this thing. So I drew up a schematic for that I shared in the last stream. Let's go back to the schematic. I have to manually switch channels now. Oh yeah, Station 240 says it's a shame we didn't get the datasheet for the USB multiplexer or the USB switcher chip. Yeah, we didn't find an official datasheet. I mean, I drew up a diagram that I think has all the features. Just pencil and paper right now, but let's see. Yeah, so I didn't really label it very well, but this is pin 1 over in that corner. So it's got a selector input, and then it has these two switches that are intended for the D plus and D minus. I didn't actually label which one of these is plus and minus. I'm not sure if it matters, but two switches that are both activated by this selector, and then I think that's an enable, but we haven't really tested that. Power and ground. But yeah, that's certainly on the full datasheet. The datasheet would have info about like voltage ranges and stuff. So yeah, the idea behind this is, over here, I didn't draw it yet, but on the left side of these resistors, you would have an I/O pin. The voltage is going to be a little important. I'm kind of assuming this is 3.3 volt I/O. This chip is 5 volt tolerant, and I'd have to go back to the datasheet actually to see whether the I/Os are set up to run at 5 volts or 3.3 volts. But yeah, if we run this at 5 volts, we might have a problem that I'll get into in a bit. But assume these are probably GPIOs that can push or pull at 3.3 volts, or high impedance, or a weak pull-up. The weak pull-up is important. So these have to be somewhat featureful microcontroller inputs, but just 3 wires. And then the series resistance here is both current limiting for the LEDs, and it provides a predictable impedance, i.e. something pull-up is important. So these have to be somewhat featureful microcontroller. The GPIOs that can push or pull. But yeah, if we run this at 5 volts, we might have a problem that I'll get into in a bit. But assume these are probably GPIOs that can push or pull at 3.3 volts. Into in a bit. But using a small RC timing circuit. Assume these are probably GPIOs that can push or pull at 3.3 volts, or high impedance, or a weak pull-up. The weak pull-up is important. So these have to be somewhat featureful microcontroller inputs, but just 3 wires. And then the series resistance here is both current limiting for the LEDs, and it provides a predictable impedance, i.e. something other than just the cable resistance, for charging up the capacitors that we'll see later. So then on the other side, this is the actual little circuit you would just embed in the tiny device that sticks to the top of the keyboard or something. Okay. So these 4 LEDs are 4 of the 6 possible LEDs that you could have in a Charlie plexing arrangement using 3 wires. Then you could kind of imagine that these 2 are like the other 2 of those 6 possible LEDs, but we're not using LEDs here, we're using silicon diodes. And then in series with silicon diodes, we have this other circuit with 2 switches, one of which is sort of a direct short, and the other connects this little RC circuit. So this might just look a little weird, but my plan for this is that, again, kind of thinking about the Charlie plexing matrix as these 6 different current paths you can energize. So the LED current paths, you'd use those basically like a scanning LED matrix. You would, if you wanted to light this LED, for example, you'd set this low, you'd set this high, and you set that to high impedance, and this LED would light. And you could do that to light any 4 of these LEDs. And so you only do that for one LED at a time, but the idea is that you scan, and then you light all the LEDs and do all the keyboard scanning on an intermittent cycle, probably driven by a timer, so that it stays consistent even if the button states change. One downside you might be thinking about already is that while you're doing matrix scanning over a long wire without shielding, this is going to be creating a bunch of EMI, and that may be a problem. I'm not planning on having to put this through FCC compliance testing, but if you were thinking about doing this for a commercial product, that would certainly be a red flag. I probably am not going to worry about that. The worst I would have to worry about is interference in my microphones, but I also think I can mitigate that by just using pretty slow scanning frequency, because I think this could suffice with a couple hundred hertz of scanning. It doesn't need to be up in audio or radio frequencies. Oh, that's cool. Leon, find us a data sheet. Let's take a quick detour. Why are you opening that in Chrome? Sigh. Oh yeah, 480 megabits.
which is what we want here. This is not something that I think you'd be able to drop in like a regular analog switch and have it work. Why are you opening that in Chrome? Let's take a quick detour. Oh yeah, 480 megabits, which is what we want here. This is not something that I think you'd be able to drop in like a regular analog switch and have it work. Yeah, that's cool. Minus 42 dB crosstalk at 240 megahertz. That's cool. It does seem like it's, I don't know. This is drawn as just a pair of switches, but they're also labeled as high-speed differential. That's cool. Thanks for finding this. This does look right so far. Select. Oh, actually, wait. That doesn't quite match the MSOP. Oh, maybe it does. Oh yeah, this matches. Cool. I was misremembering the output enables beyond that side, but this matches the diagram. Cool. And that is an inverted output enable. So this was just tied to ground on the PC board, but yeah, you could use that if you wanted to make a bigger switch. That I don't know if you'd want to put multiple of these in parallel. It does kind of seem like having a tree of them is the way to go, rather than like a bus. Okay, so we have 4 current paths. Then the other 2 current paths involve setting like the left rail here low, the right rail high, the middle one high impedance, or vice versa. So one thing you might notice is that also would light these 2 LEDs in series. Okay, so we have 4 current paths, and the other 2 current paths involve setting like left rail here low, the right rail high, middle one high impedance, or vice versa. So one thing you might notice is that also would light these 2 LEDs in. I'm relying on the voltage not being high enough for that though. If that's not the case, like if we need to run this off of like a 5-volt supply with 2-volt LEDs, and an alternative would be across the circuit, so that could be those 2 LEDs is supposed to be outside the actual lamps, but that would make your switches, so that might be what we want to do. I suspect what they want to do is make sure the voltage level not light LEDs in series, or scanning short enough that it doesn't appreciably light these LEDs, which I don't know if that's actually practical because LEDs might be sensitive. But yeah, so that's like basically it. And then these two current paths, one of these buttons looks pretty normal, so the way you would read this is you would set the right side low, you'd set the left side to weak pull up, and then you check whether the left side is low. So if it's pressed, then you end up with this floating 1 voltage drop of ground, where the right side is voltage. So that would be 0, whereas if it's not pressed, then weak pull up pulls up and it reads 1. So the non-capacitor buttons are easy, but let's say this. I mean, when it's unpressed, it just reads like normal. Weak pull up reads high. When it's pressed, though, the weak pull up would initially read low, because initially this capacitor is discharged, and it looks like a short circuit. But eventually the capacitor charged up, and I could choose to do that through weak pull up. If I read a button press, so if I'm scanning, and I notice that in one of these current paths I get 0 with the weak pull up, that means one of these 2 buttons is pressed. If I read a button press, so if I'm scanning and I notice that in one of these current paths I get 0 with weak pull up, that means one of these 2 buttons is pressed. In order to figure out which button was pressed, I have to try to charge up this capacitor and then figure out whether it's a capacitor or a short circuit. So the way I would do that is by then figure out whether it's a capacitor or a short circuit. So I think the way I would do that is by then applying a current pulse through that 220 ohm resistor up there. So set this high and this low, and then during that cycle, that's where I potentially am lighting these 2 LEDs in series, but trying not to because hopefully the voltage is low enough. But what I'm really trying to do is charge up this capacitor so that after a charging cycle, I can then do a test cycle where I set this to weak pull up and this low, and then if this reads 1 now, I know that, well, either that was a button that was released, but hopefully I can do this fast enough that I can do it multiple times per like mechanical cycle, so I can look for a stable state. So if I'm detecting a press of switch 2, that would mean that for multiple of these scanning cycles, I can watch this capacitor charge and discharge, whereas if it's this button, I would always see it as a short circuit. That's kind of what I'm planning on doing here. I don't actually know if this will work, but I think I need. And you know, the other way of doing this, of course, would be to have like ground power in serial, but that's boring. That means writing firmware, and I think this would be an interesting option. I mean, microcontrollers are pretty cheap, but I still appreciate passive components and circuits that don't require firmware. Circuit. I mean, microcontrollers are pretty cheap, but I still appreciate passive components and circuits that don't require firmware. I think that was the like kind of quick explanation monologue. I think the next part of this is just going to be some kind of chill stream while I build this on a breadboard and we can hang out with it. Are we done with the monologue? I got this tiny breadboard, but maybe I want to give myself a little more space. Tiny breadboard. I don't even know if this counts as an analog hack, but I guess it could. Tiny breadboard. I guess it's not the kind of thing you would come up with if you were thinking about circuits as ones and zeros, I guess.
old switches that I got out of a junk bin at a surplus shop ages ago. Try to put them in the breadboard here. I've got to bend a couple of leads very slightly to get it to fit in the breadboard, but I think that's fine. I might end up having to take apart these switches to put different LEDs in them, because these LEDs are really old school. They're the really old, pretty inefficient red ones.
Foreshadowing.
And for a circuit like this where I'm doing kind of a high degree of multiplexing at low currents, it might be nice to use a more modern LED. And for a circuit like this where I'm doing kind of a high degree of multiplexing, and for a circuit like where I'm doing kind of a high degree of multiplexing at low currents, it might be nice to use a more modern LED. Because that's around 3 or 4 milliamps. Modern LED. Because I'm running this around like 3 or 4 milliamps, which isn't for one of these ancient red LEDs. What is the forward voltage? Meter says 1.65. I don't quite believe that. That was what? Cathode on the right? Yeah. Let's prepare these instructor breadboarders. Yeah, if I'm limiting it to one LED at a time. Yeah, if I'm limiting it to one LED at a time, there won't have to be that much multiplexing. It's true. I can have the. I guess I was thinking that I'd want the scanning cycles to be pretty frequent, so that I could do a lot of debouncing. But I can do a lot of scanning and then just light the LEDs for a long period of time. Like I can afford to have the LED light duty cycle be pretty high. Getting out potential cable here. Thin jacks have 4 pins. I'm assuming it's sleeve, tip ring, and then 1 switch pin, but I'm not sure how the specific kind is. I think that's a switch on the tip. Mechanical.
That's what she said.
Well, maybe no, maybe that's just mechanical. These are 4-pin sockets. It's weird. I haven't seen continuity of that pin yet. It looks like it should switch pin, but maybe it's mechanical. Maybe it's like a shield on the opposite side. I don't know what that pin's supposed to be. I'm gonna ignore that. Oh, sorry, no. RC flexing, oh, that's cute. RC flexing, oh, that's cute. That's from Station 240 on YouTube chat. I like that, RC flexing. Oh, Micah flexing. Okay, James says that whoever explains the multiplexing best gets to claim the name. I guess we can do it that way. Okay, James says that whoever explains the multiplexing best gets to claim the name. I guess we can do it that way. Yeah, I'll give you a recap while I'm doing the soldering here. So the topic we're doing. This is another little side project. It's just a thing that I needed for my shop. This is a USB switch that I use to have a single mouse keyboard, face mouse, tablet, whatever, so user. And I've been frustrated by it because I always like going to button, never quite sells this button I'm talking to. And I'd rather have a separate button that just press one to channel. I'd also have buttons using separate switches that have this be like on my keyboard or something. So the obvious solution, I think, for a lot of us might have been to have this be another microcontroller that sends a serial message over to this microcontroller. And we still might end up doing that if this proves to be annoying, but I wanted to try something where instead I try to conserve wires a bit and use just a little audio cable with 3 wires to drive 4 LEDs and 4 LEDs and.
Alright, I need a brief break. I'll be back in just a second. Here's the cat.
Oh gosh, I like that idea. Alexa suggests that beer would go pretty well with the stream, but they don't have a beer. I don't have a beer either. Gosh, and if I left to get a beer, then we'd have the same problem. We'd have beer and no stream. That might be a problem. Well, I've got coffee, which is like the opposite of beer. I don't think my stomach wants the coffee anymore. I think I made more than I needed today. Oh gosh. I think I need a brief break from editing dialogue. I have a hard time doing this for too long, just like in one stretch. I do a couple minutes of Twitch plays Duolingo or something. I've unlocked leaderboards, huh? Interesting. I guess I thought the leaderboards were iOS only. I've only recently tried using the Duolingo website, and I'm discovering what the differences are between the iOS app and the website. Can I test out of any of these?
Señorita Rivera.
Never quite sure how they want me to translate the. I don't know, like some of the like honorifics in Spanish don't seem to have direct translations, and I'm not quite used to what Duolingo expects, but maybe that's
Buenas
just me.
tardes, señor.
Oh,
Carmen
right.
está muy ocupada. Hola, ¿cómo te llamas?
Señor, ¿cómo se llama usted?
Juan no está cansado. Señor Albert, ¿cómo está usted?
La niña está muy feliz.
José no está bien.
Ella está cansada.
Oops. Oh, they wanted me to use this instead. See, they wanted me to use Senorita there. How was I supposed to know? That was the problem I kept having with this particular one. I've been really skipping around though. Like I've unlocked most of these just from, like there was something where you could like take a test and like unlock an entire section. Because I used to study Spanish in school, but it's just been a long time since I practiced it, and I felt like trying Duolingo. Anyway, maybe I'll get back to work instead of messing around. Around like 3 or 4 milliamps, just a lot from these ancient LEDs. Okay, James says that whoever explains the multiplexing best gets to claim the name. I guess we can do it that way. This is another little side project that's just a thing that I needed for my shop. This is a USB switch that I use to connect a single mouse. Just a lot from these ancient LEDs. Okay, James says that whoever explains the multiplexing best gets to claim the name. I guess we can do it that way. This is another little side project that's just a thing that I needed for my shop. This is a USB switch that I use to connect a single mouse keyboard, face mouse, tablet, whatever, to my computer. And I've frustrated by because I always like really nice that work quite sells this on to. And I would rather have several buttons that you press one to go to the channel. I would also have separate connectors, and have this be on my keyboard. And have this be on my keyboard. The obvious solution, I think, for a lot of us might have been to have this be another microcontroller that sends a serial message over to this microcontroller. And we still might end up doing that if this proves to be annoying, but I wanted to try something where instead I try to conserve wires a bit and use just a little audio cable with 3 wires to drive four LEDs and 4 switches. So, yeah, there are ways to use a really cool example. One thing that I think I was thinking about this, we have like a channel, just like a channel. Which I might feel like it doesn't have much feedback, but if we did things, we have to super in one. And that could be satisfying. So that still might be nice to do. That would have mechanical feedback, so turns. We need LED indicators, so there's just one here. But if I could use these light buttons and have push on it. There's other ways to do this, like I imagine like a little latch circuit that latches on the turns and then send out like time pulses based on place. There are ways to do this in circuitry. It just seems simple because it requires passive components and really all the timing and everything requires a stable power supply. Everything requires a stable microcontroller and there needs to be a stable power supply. I also don't necessarily want to put a lot of power over an audio jack because these tend to short out as you're inserting and removing them. So I probably have a current limited power supply with like a resistor maybe, and then capacitor filter, and then like a low voltage tolerant microcontroller. I don't know. There are a lot of ways to do it, but then that starts to eat into your budget for like serial timing reliability and stuff like that. So yeah, and I'm going to do. That's the idea. I don't know if it works, but that's the idea. It's the last video of my sort of. And the RC circuit is a bit weird too because you've got that diode in there, so you can't actually discharge the capacitor through the GPIOs with the diode. So you need that resistor to set the discharge time to something reasonable, otherwise you're just going to be relying on the leakage. David's wondering if the port could be selected by a keyboard that's connected to this. Yeah, some switchers work like that. It was a lot more popular when PS2 keyboards were a thing because then you just listen to PS2 connection. With USB keyboards, you kind of need to have like a full-on USB converter, which is a thing to do in the future, that's not this project, or you need to modify the keyboard itself to attach. Like, just kind of easier and more durable to make a nice connected keyboard than actually having keyboard. Oh yeah, the audio cable sorting problem, that'll definitely even know about insert 20 parts over cable. I had a problem when I was sorting electronics. I was trying to power over a telephone cell connector. Those don't usually short, but they're very good for sorting. I started this hard way. I left that. Alright, just making these little same jocks on my little keyboard sorting. It's very old, punch line more number 2. You can see we're still chips in there. There's not much sorting, I
don't know if I'm going to need much of the audio from this upcoming section, but some of the video might be interesting. Why not? I don't know.
It's a very old, kind of time-worn breadboard too. You can see yourself. I don't know, like it's tempting to just go ahead and attach it to the circuit side, but it's probably easier for cables on the breadboard. I think the other side of the breadboard. It's not sorry for micro. I think I chose a couple pins there that would be easy access. There are a couple pins there for unused features and go to, so Mr. Vito. That's the idea. I want to see the same time. Maybe the first seconds. I actually was. I'm very slow with the I was just very confused. Key clacky button that never quite settles into the spot that I'm expecting it to, and I would rather have a set of 4 buttons that I can just press one to go directly to one channel. I would also rather have the buttons be physically separate from the actual switchers, that I can have the cable mess be over with the cable mess, and then have this be like on my keyboard or something. So the obvious solution I think for all of us might have been to have this be in the microcontroller that sends a serial message over to this microcontroller. I'm still doing that, it's pursuing, but I want to try something where instead I try to conserve wires a bit and use a audio cable for wires of components, and really all the timing and everything that requires a stable power supply is on this end. Everything that requires a stable microcontroller and there needs to be a stable power supply. I also necessarily want to put a lot of power over an audio jack because these tend to short out as you're putting everything. So I don't currently power supply with like a resistor maybe, and then capacitor filter and a little voltage microcontroller. No, there are ways to do it then. That starts to get into budget for like serial timing and stuff like that. If I'm selected by keyboard to this. Yeah, some switchers work like that. That was a lot popular when PS2 keyboard was a thing, because then you could just listen to the PS2 command. USB interposer, which is a thing I do in the future. That's not this project. Or you need to modify the keyboard itself attached. Oh, Alexis, you're right. Animals are the best. I'm gonna go cuddle Tuco for a sec. Okay, I think that helped. It's a very old, kind of time-worn breadboard too. You can see where several chips have melted on here. No, sorry, there are a couple of pins that are for unused features. I would do minutes to render audio previews. actually labeled all this. Let me fix exactly what's got it. Otherwise, I'm very confused. I don't know that 220. Hey, that's pretty good. Resistors inside most of this spec usually currently everything is It is not an ESD solution on its own, but it makes the job of the existing ESD diodes a little easier. Resistance. Resistors go on this side mostly because that usually currently everything is still cover. You could go to the side and use that functionality. Also, shock absorber ESD. That's on purpose, really. Sleeve and that acts as kind of a common for all the LEDs, but it isn't used by the capacitor. And this is also on between all switches. Works. I think we can make a simple milled circuit board for it.
Kind of want to run this segment of footage through that time or motion sensitive time compression tool. I haven't gotten to the bottom of those crashes I was having though. Plus on the left for these. So that's the sleeve, and that acts as kind of a common for all the LEDs, but it isn't used by the other half of the circuit. This is also common between all switches. a bit of a board. Head over there, see breadboard. If this works, you can make a simple build circuit board. This ring and a wiring tip. Just 2 of these and I have diodes. I was just going to use whatever's in here, which is probably 1 in 4,000 watts. Cut off the sticky part. Pretty sure we're going to need the oscilloscope to debug this. Not just to demonstrate how it works, probably to debug it. Okay, so those are the diodes attached to the common on the tip side. And those go directly to switches 1 and 3. You can see the switches through there, kind of. Alright, so that's everything except for the RC switches. The secret sauce. It's got 4 resistors.
want to be higher than 1K. This is just kind of a starting point. You could use non-polarized capacitors for that. For this is just really handy. James is wondering if we'll end up getting some debuffing for free on the circuit. You can do that, I think I'll just start anyway. I think I'll just be doing multiple matrix scans and looking for like wing detection plates based on system. Okay, a couple more wires. Yeah, just put together board so I can write code on there. Just as a first. Okay. Focus. Focus. There's my 2 in series. You're dim with the overhead lights here. Focus. I guess that does it. Fine. It's like possibly done. It's just like years not being tracked. Just need a lot of these business. Cool. So those are the two middle LEDs. Two outer LEDs. Cool. And then I'll see Taylor values. Two outer LEDs. Cool. And then the switches. Oh yeah, and so these combinations with the meter, I am going to see at light 2 LEDs. I don't know if that's going to be a problem with 3.3 volt logic. Probably not, but we'll cross that bridge if we come to it. Oh yeah, none of those detect this continuity because of the diode drop, but if I go to diode detect mode, these two don't do anything. That one gives me a diode drop of 0.6 volts steady. That's interesting, this just reads as a diode drop of 1.5 volts. Right now I'm just kind of looking for something that's kind of reasonable, but I'm not really expecting this to be that close to reading it as a real Charlie Post matrix. Just trying to see if all the correct paths do something about what I'm expecting. This looks right. Cool, let's move on. I think the next step then, so this is prototyped. Should match the schematic, seems to work so far. Should match the schematic, seems to work so far, still can't quite actually test it. The next step is to modify this side so that we have GPIOs exposed. Need to pick some GPIOs first. By this side so that we have GPIOs exposed. Need to pick some GPIOs first. Okay, where were we? Cool, let's move on. I think the next step then, so this is prototyped. Should match the schematic, seems to work so far, still can't. So this is prototype. So this is prototyped. Should match the schematic. Seems to work so far. Still can't quite actually test it. Next step is to modify the site so we have GPIOs exposed. The next step is to modify this side so that we have GPIOs exposed. GPIOs first. Maybe get the light back. So yeah, this is just a scribble of the microcontroller with what the pins are being used for. So we've got the existing 4 LED outputs. So we've got the existing 4 LED outputs. 3 selectors for the actual USB switches. We have an unused infrared input, which seems like a good candidate for this. There's also this pin, which is just tied to ground. This pin, which is just tied to ground through a 10K resistor, which also seems useful. Oh yeah, and then this one is also unused. Oh yeah, and then this one is also unused. It's tied to enable on some of the microcontrollers, or some of the switches. This pin, which is just tied to ground through a 10K resistor, which also seems useful. Oh yeah, and then this one is also unused. It's tied to... This one is also unused. It's tied to enable on some of the microcontrollers a 0 ohm resistor, and so it's actually not being used right now. We can just pop that 0 ohm resistor off and use that as a GPIO. So... yeah, and that's actually what I wrote on this sticky here. So I think we want pins 2, 13, which is IR, and 20. Pins 2 and 20 also have analog, but I don't think we need that right now. But I think these are our GPIOs. So let's unplug this from power and maybe go back into the microscope or something. Easy. I also might want to put a header in there, because I've just got the debug adapter soldered pretty haphazardly to the board right now.
Yeah, I go on this whole tangent to put a header on this board, which I didn't bother doing earlier.
and 20. Pins 2 and 20 also have analog, but I don't think we need that right now.
Gosh, the autofocus was just going nuts in this scene. I'm gonna have to do something with that video to make it usable.
So I think we want pins 2, 13, which is IR, and 20. Pins 2 and 20 also have analog, but I don't think we need that right now. I also might want to put a header in there, because I've just got the debug adapter soldered pretty haphazardly to the board right now.
Yeah, it might be nice to swap this coffee for some pizza and beer soon. Seems like it could be nice this evening. But, there's just always so much video to edit. Like, I mean, we've been at this for, what, only less than 3 hours, and I already feel like I'm just so done with this. That's usually how it works with video editing. You have to take frequent breaks, otherwise it just overwhelms me with how tedious it is.
This looks like it's not 0.1 inch pitch.
Not 0.1 inch pitch, yeah.
It isn't 0.1, but I can probably make 0.1 fit if I wanted to.
It is not 0.1.
Should I label pin 1 on this device?
I just totally did that, didn't I?
Should I label pin 1 on this device?
Sure, why not?
Pin 1 on this device.
Cooler.
So I think for this, I just want to have the header kind of hover above the circuit board over here. And I think I can solder it such that it actually makes contact with all 4 pins. It just won't be very mechanically sturdy.
Do I even need to talk about this? I already mentioned the signals earlier. I think this is just going to appear as some kind of continuity change at some point. I'll decide whether to throw away these clips later.
Right.
Connector, but
What am I do with this? Yeah, I don't actually have the right connector, but what am I do with this?
oh, hey, Tuco. Finger cam. Oof. Get out of the way.
Green tip for this.
Tuco, what are you just drawing down there?
I really do. I should switch tips because I'm gonna do
Ooh, wow.
all our stuff next.
Tuco. Tuco. No? Oh my gosh, Tuco, don't be under the camera tripod. Tuke. Oh, now the camera is tracking him automatically. It's not too bad so far. I mean, I guess I feel like after this first pass of editing, I'm guessing that this is probably going to turn into 3 or 4 hours of video after that pass. And then maybe another couple of editing passes, depending on how I choose to do it. I mean, I could turn it into, I don't know, like an hour of kind of straightforward, like project log kind of video, or I could do something more interesting with the bulk of it. I don't know, I was talking about that a bit more earlier, just trying to figure out what form most of this should take and how to split it up, if I split it up. I should really label pin 1 on this device. I'm just putting in a different soldering iron tip, right? Oh. Was I recording the microscope here? Tuco, what are you doing here, honey? Oh, I was not recording the microscope. Whoa, Tuco. Cat. 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 Oh gosh, I think my stomach's getting cranky from mostly only knowing about coffee today. These are temporary, it just needs to last long enough for me to do some debugging. So these are temporary, it just needs to last long enough for me to do some debugging. Well, not even debugging. I haven't actually set up a source level debugger yet. Or, yeah, any debugger, I've just been using this for flashing. There is some relatively recent support for OpenOCD on this platform, but so far I've been using this other special purpose tool, it's just for STM8 flashing.
This one's a power plane. Or ground plane, maybe? One of those. First. Alright, so pins 2, 13, and 20. So 2, in the original firmware, this one's being used as configuration. So I think it reads that pin on startup and uses it to switch between a 2-port and a 4-port mode. This firmware doesn't really implement the 2-port mode, so it'll just be kind of arbitrarily broken if you remove this resistor. But I don't think I'm going to run the original firmware on here much anymore. Alright, so pin... Yeah.
Oh, Tuco's climbing.
Alright, so pins 2, 13, and 20. So 2, in the original firmware, this one's being used as configuration. Long enough, we're going to do some debugging. Alright, so pins 2, 13, and 20. So 2, in the original firmware, this one's being used as configuration. So I think it reads that pin on startup and uses it to switch between a 2-port and a 4-port mode. This firmware doesn't really implement the 2-port mode, so it'll just be kind of arbitrarily broken if you remove this. So I think it reads that pin on startup and uses it to switch between a 2-port and a 4-port mode. This firmware doesn't really implement the 2-port mode, so it'll just be kind of arbitrarily broken if you remove this resistor. But I don't think I'm going to run the original firmware on here much anymore. I hope. It's a lot more to keep warm on the right side of this than the left, it looks like. I mean, that is the ground plane, I guess.
Tuco just knocked the headphones off my desk. He likes earbuds. Like, I think he just likes the way ears smell or something, so he licks my earbuds. He's a weird cat.
This firmware doesn't really implement the 2-port mode, so it'll just be kind of arbitrarily broken if you remove this resistor. But I don't think I'm going to run the original firmware on here much anymore.
Tuco, what are you doing, honey? This is such a silly way to remove a resistor.
But I don't think I'm going to run the original firmware on here much anymore.
Tuco, what are you doing, honey? Dude, what do you want? What do you want, Tuco? Wow. What do you want? Hmm? Ow.
I'm going to run the original on here much anymore. I'm like, keep it there just for safekeeping, but I think I do need to use that pad. use that pad. I think we'll figure that out in a sec. It's done 13. I think that goes directly to the IR. Let's check that. I don't think there's a resistor to get rid of. So okay, so far our GPIOs are this pad now, this pad, and pin 20, this. So, see, this is a selector for the first USB switch, but it's strapped to ground over here. So I think the idea is that you could populate this differently by leaving out R7 and putting in R14, and then you have software control over the switch, or you could leave in R7 and leave out R14.
Tuco, honey. I think the outside world is conspiring to distract me at this point in the day. Tuco. Wouldn't have software control. Okay, I think this is the point in the stream where if I keep trying to work, Tuco is just going to make my life as frustrating as he possibly can. So maybe I should just hang out with him for a bit and then work by myself. 7. Tuco. Well, thanks for hanging out. I think I'm gonna wrap this up there, but I hope that was interesting for some folks. I don't know if the video editing streams are really that interesting for folks, but I felt like having a co-working stream, this is what I needed to work on. So, all right. Well, let me know what you thought. If you want me to do more of these, or if you just want me to keep the streaming to only the like physical world projects or stuff that's less meta, that's fine too. Anyway, and special thanks to everyone who keeps the channel going by donating via Patreon or by, sending in whatever you can to help out, whether it's hardware or, sending your friends this way or tossing a couple bucks my way. It all helps me just keep this going as much as I do. And if you want to help me try to focus on a particular thing, then let me know what you want to see more of, and I'll try to take that into account too. But yeah, if you do find it useful to hang out while I'm doing the video editing, then let me know and I'll try to do more of this. We could certainly talk meta shop stuff. We could also just quietly work together. Those are both kind of alright options. So anyway, I think I'm gonna go hang out with Tuke a bit before he gets super restless, but thanks everyone for hanging out and for supporting the channel, and I will see you all next time. Happy hacking.